Welcome to my 6-part tutorial series to teach you how to make a platformer in GameMaker. This is part 2 of that tutorial, and thus far we have momentum-based movement. So it sort of builds up to a max speed and then slows down when you're not moving, holding a direction button. We also have a variable jump height. So if you just tap the jump button, you go a little less high, and then if you hold, you go higher. And we have a collision system, so the blocks here collide with the player. Now, I saw a comment on my first video that the collision system I'm using in this tutorial, using the rounding of the X and Y locations of this player object might be causing issues for some people. Don't worry about that. If that's the case, just strip all that out and go back to a basic collision system that I cover in my first tutorial series. And yeah, just do whatever works for you. Anyway, in this video, we are going to add some wall jumping mechanics. We're going to add enemies, an attack system, and a checkpoint system. So let's go ahead and get started. Let's open up our OPlayer object. And in the current status region, we need to check if the player is currently touching a wall. So underneath our var on ground variable, we're going to declare a new local variable called underscore on wall equals place underscore meeting x plus 1 y o block minus place meeting x minus 1 y O block. So what this does, it actually gives us directionality. Here, let me expand this out a little bit. So if we are touching a wall on our right, this will be 1. This function will return 1, and this function will return, I changed this to, sorry, minus 1. This function will return, I'm missing something else. Place meeting, because I added a parentheses there. There, I got to get rid of my excess parentheses. So place meeting x plus 1 y o block minus place meeting x minus 1 y o block. So this will return a 1 if we're touching a wall on our right, and this will be 0. So 1 minus 0 is 1. So on wall will be positive 1 if we're touching a wall on our right. And if we're touching a wall on our left, this will be 0 minus 1. So it'll return minus 1. So on wall will be minus 1. So on wall will be 0 if we're not touching a wall, minus 1 if it's a wall on our left, positive 1 if it's a wall on our right. And we're going to be using that to give us a lot of useful information. Now, also, I know that you noticed, maybe you didn't, I added some small level design to allow us to test wall jumping here. So you should probably pause the video and edit your levels so that we have some places to wall jump off of back and forth. All right, so next we are going to add a sprite for when the character is on the wall. So go to create sprite, call this S player wall, import the appropriate image. It's only one image, S player wall. Origin middle center, frames per second is 0. Now go to the sprites region of our OPlayer step event. And we want our new wall slide sprite to override the sprite that we have for when the player object's in the air, which is our jumping sprite, because we are also going to be in the air, but on a wall. So if we're in the air, not touching a wall, it'll be one sprite, but if we're in the air touching a wall, we want it to be a different sprite. So navigate to this bang on ground or not on ground section here. And we're going to make an else statement to house everything that used to be here for jumping and falling. So I'm actually going to write a new condition. If not on wall, else, and then I'm going to copy these 3 things and put it here in this else statement. I properly indent it also. And then here we can add our information for our wall sliding sprite. But first I should add some comments. So if in air not touching wall, if in air, oh, comment, if in air touching wall. And we'll write sprite index equals s player wall, image x scale equals underscore on wall. So this will tell GameMaker to flip the sprite to be flipped if this is -1 or regular if it's +1. So that's why we have the on wall coded that way. So we should check to see if it works now. Oh. Well, obviously it did something funny here. And I gotta find out what it is. Oh, it's this. I'm doing a lot of bugs this time around. It shouldn't be not on wall. It should be underscore on wall does not equal 0 because on wall is not a Boolean. It is an integer number, -1, 0, or 1. Okay, there we go. Sorry about that. So now it gives us a new sprite, our wall sliding sprite, but it still has our jumping sprite appropriately. There we go. So let's get started coding our wall jumping and sliding. So in the create event first, under speeds, let's declare some new variables. Gravity for when we're on the wall, because we actually want to slide down slower than when we're just in the air. So grav wall equals 0.1, semicolon, gravity reduced when sliding on a wall. And grav max wall equals 5, semicolon, new comment, max falling speed when wall sliding. So this gives us a max falling speed when we are sliding down. And we can change that if we wish. Because right now our max falling speed right now is 12, but our max falling speed when we're on the wall is going to be 5. And now under jumping, we need to add variables for wall jumping. Wall jump distance equals 7. Max HSP for moving away from a wall during a wall jump. And jump height wall underscore wall equals -9. Comment how high you jump during a wall jump. So normally our jump height is -12, but when we're jumping off wall, we don't want the character to go as high up, but you can adjust this. These are all numbers that you can adjust and play around with and find what works for you. So now we'll go to the step event, and we're going to go to the horizontal movement region and create a new region underneath it. And we want this before, or a new section underneath it. We want this before the vertical movement section. So right here at the end, we will write wall jump. If underscore on wall does not equal 0, and, so double ampersand, or you can also just write and, but I like doing this, not underscore on ground, and underscore key jump, open curly bracket, close curly bracket. So this means, I'm going to write a new comment, on wall, in the air, and jump key pressed. New comment, change HSP to be opposite the wall, jump away from the wall. HSP equals negative underscore on wall times wall jump distance semicolon. New comment, change VSP to jump vertically differently than from the ground. VSP equals jump height wall semicolon. And in the first line of the vertical movement section, we're going to replace this VSP plus equals grav with a new chunk of code to determine what gravity we need to be using at any given point. So we're going to just replace this, just delete it. We're going to write a big old section here because we have gravity when we're in the air and then gravity when we're on the wall. So var underscore grav underscore final equals grav semicolon. So new comment, import grav value from create event. Var underscore grav max final equals grav underscore max semicolon. New comment, import grav max value from create event. Condition, if underscore on wall does not equal 0, meaning we're touching a wall, open curly bracket, close curly bracket, comment, if on a wall, new condition, if VSP is greater than 0, open curly bracket, close curly bracket, new comment, if sliding down on that wall, underscore grav final equals grav wall, semicolon, new comment, slide slower than in the air, underscore grav max final equals grav max wall, semicolon, slide slower than in the air. And then here, if on wall, we're going to do an else statement here for the on wall condition. So here, if we're on a wall, it'll do this, else down. So this means, new comment, if not on a wall, just normal gravity should apply. We can write underscore grav final equals grav. And after that, we write, after all these conditions, VSP plus equals underscore grav final, VSP equals clamp, VSP, comma, jump height, comma, underscore grav underscore max final. There we go. Close parentheses, semicolon. But it's very important. We already have a clamp for our VSP that comes later. We need to delete that. So let's scroll down until we find it right here, right on minus line 86, right at the very end of the vertical movement section. I'm just going to highlight that and delete it. And here we have the new clamp, so we can test it out, and we should have some wall sliding. Actually, I'm going to go into R level 1 and just delete that really quick. So we do slide down slower, and there is a small wall jump away, and we do face a different direction when we jump away. There we go. However, you can see a problem, hopefully already, if you're testing this, is that you can climb walls like this by repeatedly pressing the jump key and just holding the direction key towards whatever wall you're facing. So if I hold left here, just keep holding the jump key or pressing it, I can just climb up the wall like that. Now, in your game, if that's what you want to have happen, great. That's the game you want to design. But I want it so you kind of like lose control for a bit after you jump away from the wall, more like a Mario wall jumping. So let's alter our code a bit now. For this, I'm going to return that part of the level. So to fix this, we want to go to the create event and declare a variable. Under jumping, I'm going to add a new comment here. Player loses control for some frames after a wall jump. The variable is wall jump delay equals 0 and wall jump delay underscore max equals 15. Now we go to the step event, to the horizontal movement region, which is this. And we make the very first line. Should we put it under where we get our dir? Yeah, we can just make it the first line. Yeah, it should work just fine. I care about that because in a step event, it runs code in this order for each step. And so sometimes that matters. And I think here it won't matter at all. So I'm going to add a new comment. We'll reduce wall jump delay by 1 every frame until we hit 0. Wall jump delay equals max, open parentheses, wall jump delay minus 1, comma, 0, close parentheses, semicolon. And now we are going to wrap the entire section of this horizontal movement region in a condition. We're going to add a new comment here. Won't be able to move left/right until this equals 0. If wall jump delay equals 0, open curly bracket, and I'm going to scroll down to the very end of this region, add a close curly bracket, and I'm going to highlight all of this and hit tab to indent all of it. And in the very first line of the wall jump if statement, I'm going to add wall jump delay equals wall jump delay underscore max, semicolon. New comment, just wall jumped, so no horizontal control. So let's see if it works. So we jump. So I am holding down left, and you can see that I lose control for a certain number of frames. And I can no longer climb a wall just by holding that direction key. And you can adjust the wall jump delay max value to see how it changes the controls, like with changing any of these values. And lastly, for wall jumping, we are going to make it so the player can keep holding a direction key while wall jumping without coming unattached from the wall. So right now, if we run the game, and if I'm about to climb up this section and I'm just holding the left direction key constantly, I'm just holding it. So I'm holding it and I start wall jumping and I get to the other wall. After I get control again, I move away from the wall. But what we're going to do is I can just keep holding that. And as long as I'm wall jumping, it's going to ignore that, which is going to be very easy. So we're going to add this condition in the step event in the horizontal movement region where our dir gets declared and defined. Right after that, we're going to write if open parentheses underscore on wall does not equal 0 and not underscore on ground close parentheses, open curly bracket, close curly bracket, underscore dir equals 0. So what this is, if new comment on wall and in the air, we are automatically going to set our dir to be 0. So it will not be taking in new directional input. Run the game. So now I'm going to hold the left key constantly. I'm not going to let go of the left key. I'm going to just start jumping, and I'm not becoming unattached from the right wall, even though I'm holding the left key. And the only way to come off this wall is to slide off. And it just feels more natural when I'm like running and I just hold that key and then I get over here. And that's how games like Mario Odyssey does it. You can hold the direction key and you will not come unattached from the wall. It just feels natural. So we got our wall jumping now. So now we need to add some enemies and some hazards. So for that, I am going to just adjust our levels slightly. So we have to test wall jumping here. And I'm going to test our enemies here. And I'm going to test our hazard right here, actually. So let me remove that. And our hazard is going to be over here that I can test. And this will make sense in a moment when I start placing those sprites. So all platformer games have some kind of have hazards that you need to avoid, and that literally defines the genre. Like, don't fall off the platform or you'll touch something that will, cause a game over. So to add the hazards and our enemies, we're going to use a parent object that's just going to be called bad, like things that you should not touch, and that's going to dictate the behavior for when our player touches it. So we're going to create a new object, call it bad. And that's going to be our parent object. So now create another object, call this hazard, and set its parent object to be bad. So it will, hazard will now inherit whatever code we add into bad. And also if we add any code that references this object bad, it will also apply to hazard. And also, this other object we're going to create, new object, enemy. Also set its parent to be bad. Now let's create a new sprite called hazard. Import, this is in a different folder, hazards and enemies, hazard 0 to hazard 5, open. And set the FPS to 10, and the origin should be top left, just for placing it easily in the room. So it'll look like this. Create another sprite called enemy. Import the image, it's just one image, enemy. Set the origin to be middle center, frames per second to be 0. Now set the sprites to their appropriate objects. So hazard gets hazard, and enemy gets enemy. Now in player step event, I'm going to minimize that region. We're going to create a new region at the bottom of or near the bottom of the step event region, and we're going to call this enemies and region. And we're going to write new comment, game over. If place meeting x, y, bad, we touch any object with the parent of bad, game _ restart. Open, close parentheses, semicolon. Now open our room editor and create a new layer over here and rename it either by pressing F2 or right-clicking, going to rename layer, and call this one bad. We're actually going to drag it underneath our instances layer. Make sure it's highlighted, and we are going to add some of these objects here. So I'm going to add hazard here, and we're going to add enemy here. Highlight instances layer and actually get rid of that right there. Yeah, I want to make it so this enemy has more room to move. Well, let's just do that. Beautiful. So I'm going to just verify that our hazards and enemy got added to the bad layer. Everything else is in the instances layer. There we go. Now let's run the game to make sure we haven't glitched anything out. And we have OPlayer event step at line 157 got curly bracket instead of close parentheses. Okay, so that should be easy. Line 157. Yep. I have 2 open parentheses, and so I need 2 closed parentheses there. Very good. So our enemy is there, our hazard's there. Now, right now, if I touch it, the game restarts. The game restarts. Yep. All right, so to make it seem more natural in terms of the collisions, right now you don't even see the player touch either object because the moment you do, the game restarts. So we can adjust that to make it look more natural by adjusting the collision masks here. So right here, it sets the automatic collision mask to be right there. We want it to be lower. So I'm going to go to manual, click this. I'm going to put it right down here. And enemy, enemy, I mean, collision mask. Manual, let's put it so you actually see it being touched. We do want the lower collision mask to be all the way to the ground because we're going to use gravity on this enemy. So now when we run the game, you actually see the player actually touch the spikes and the game restarts, and we actually see the player touch the enemy. Excuse me. All right, so let's make it so the enemy moves back and forth. And so that'll give it some enemy behavior. We're going to open enemy, and we are going to add a step event. And we're going to write the following code. HSP equals current underscore dir times HSP underscore max. These are variables we're going to declare in the create event in a moment. And we're going to call this new comment calculate horizontal movement. New comment calculate vertical movement. VSP plus equals grav. VSP equals clamp. VSP comma negative VSP max comma VSP max. So this is just a stripped down version of movement code from OPlayer. You'll see some similarities. We need to declare these variables in a moment, but we're going to write a simpler version of our collision code here. And this is the similar collision code that you could replace in our OPlayer step event if the current collision code isn't working for you. So horizontal collision if place meeting x plus HSP, comma y, comma o block, close parentheses, open curly bracket, close curly bracket, var underscore pixel equals sign HSP, semicolon, while bang place meeting, open parentheses, x plus underscore pixel, comma y, comma o block, close parentheses, x plus equals underscore pixel, HSP equals 0. So this is how the collision code will work. Would work if you simplified it in OPlayer. In fact, you can use this simplified collision code in OPlayer if you like. Same with the vertical collision. If place meeting x y plus VSP comma o block, close parentheses, open curly bracket, close curly bracket, var underscore pixel equals sign VSP, close parentheses, semicolon, while bang place meeting, open parentheses, x, comma, y plus underscore pixel, comma, o block, close parentheses, y plus equals underscore pixel, semicolon, VSP equals 0, semicolon. Comment, commit to movement, x plus HSP, y plus VSP. And we'll add a create event, declare necessary variables, which are HSP equals 0, VSP equals 0, HSP underscore max equals 2, VSP Oh, so by the way, this is comment movement speed. VSP underscore max equals 10, semicolon. That is max falling speed. Current underscore dir equals 1, semicolon. 1 is right, -1 is left. Grav equals 0.4, semicolon. Gravity. So let's run the game, see if it works. Oh, enemy step event, line 23. Line 23. Oh, I did plus, but I need to do plus equals. X plus equals HSP, Y plus equals VSP. There we go. Always look at your errors. It'll tell you exactly where your problems are. So our enemy object is now touching the ground appropriately, and it does move. But now we want it to change directions when it touches a wall. So right here after HSP equals 0, add current underscore dir multiply equal -1, semicolon. New comment, change direction. So this will just flip the direction whenever it touches the wall. So if I hit run, it'll touch that wall and it'll go the other direction. Now you see it overlaps with the wall a bit. That doesn't really matter to me. I mean, you can adjust the collision mask here to be more to left and right, or even like all the way here if you want. But yeah, I don't mind it at all, because I'd rather have more natural collisions with the player, or natural feeling collisions with the player. And now to make the, let's see, I'm going to add another, yeah, we're going to add another enemy here, because we want the enemies to change directions if they touch each other. So we'll add 2 enemies here so they can touch each other. All we have to do is under horizontal collision, we just copy this, paste it, and instead of O block, we change this to O bad. And O bad. And this will make it change directions and also collide with each other. Yep. So now the enemies will change directions when they collide with a wall or with each other, which seems more natural. And our collision still looks pretty natural. Good. So let's add checkpoints before we add our combat system. It's relatively simple to do, because when what we want to have happen is, instead of restarting the game whenever we touch a hazard or an enemy, we want to return to a checkpoint. Let's create a new sprite, s checkpoint, import, and this is going to be under other sprites, I believe. Yes, checkpoint 0, checkpoint 1, open, FPS of 0, origin, middle center. And we're going to create a new object, O checkpoint, set the sprite accordingly. And before we add any code here, let's add a splash room. A splash room is a room that runs before the rest of your game, and it's great to just run certain code before the rest of our game. Now later we will be turning the splash room into a title room, but for here, let's just call it splash. So let's go to create a new room. Come on, where are you? There you go. Our splash. And the word splash, I just use it as like a temporary room, a room that runs before the rest of your game. And after we create our splash, the first thing I'm going to do is right here, if you hover over our splash, you'll see a little double arrow sign here. You click that, and this is where we can change the room order, and you just click drag our splash and move it to the top. So our splash is at the top, and it has that little home icon next to it. Exit out of that. Now our splash is the first thing that will run. We change the dimensions to be the size of our game, which is 896 wide, 576 tall. And we're going to open our creation code and declare some global variables. Wonderful things I believe I covered in my last tutorial, but they are variables that anything in the game can access and modify. So global.checkpoint global.checkpoint underscore room equals no one, Noone, no one, meaning no room. We could also change this to R level 1. Actually, I'm going to do that. Our level 1 is going to be our checkpoint room that we declare. Global.checkpoint underscore x equals 0, semicolon, global.checkpoint underscore y equals 0, semicolon, global.checkpoint underscore ID equals, for that we will do no one. Room, go to R level 1. And let me just change something on my notes really quick. So this will declare some global variables and automatically go to R level 1. So let's run the game, just make sure we haven't broken our game. Yeah, we still open R level 1, which means everything's working. Exit out of that. Now go back to our checkpoint object, and in the step event, add that. Right, comment, change sprite if it is the active checkpoint. If global.checkpoint underscore ID equals ID, which is this particular instance's ID in the room, close parentheses, open curly bracket, close curly bracket. Actually add an else here, else, open curly bracket, close curly bracket. Indent image index equals 1. So if it is the active checkpoint, it'll be this sprite or this image, and if it's not the active checkpoint, it will look like this. So this is 0, this is 1. So here we will add image index equals 0. In our level 1 instances layer, let's first change the name of the instances layer to be more descriptive. We want this to be the player layer, so rename it to player. It's a little more descriptive. And we're going to add a couple of checkpoints. Let's add a checkpoint here, here, and let's change the grid so it's a little smaller, 32 to 32. And here, just to test it out. Move the player a bit. Actually, let's add a new layer called checkpoints. I forgot that makes a little bit more sense. So I'm going to add a new layer and call it checkpoints. Sorry about that. I'm going to move it below our player layer. And I'm going to highlight the player layer, quickly delete these, and re-add them to our checkpoints layer. There we go. Pretty fast. Now we want the game to record some variables if we touch a checkpoint. So in the oCheckpoint object, in the step event, in this else statement, meaning we're not the active checkpoint, below image index equals 0, write if place meeting x, y, o player, meaning if our player touches it, close parentheses, not going to make that mistake again, open curly bracket, close curly bracket. Let's redefine those global variables. Global.checkpoint room equals the room that we're currently in. Global.checkpoint underscore x equals x. Global.checkpoint y equals y. Global.checkpoint ID equals ID. So this means that if it becomes the active checkpoint, it records the room we're in. The horizontal location of the checkpoint is going to be our checkpoint for our player. The vertical location is going to be also set, and the ID of which instance of the checkpoint object is the active one or the most recent checkpoint will be changed, so the sprite changes accordingly. So let's run the game, and we should see our sprite change. So I touch it, and it gets highlighted with that flag as the active checkpoint, and the other one gets unhighlighted appropriately. Alrighty. Now we'll need to make the player go to the last checkpoint if they touch an enemy or hazard. And the very first thing you have to do, don't forget to do this, is open your level under the player layer, click the player object and remove it, because what we want to have happen is the room to create the player object and then move it to where it needs to be every time. In our level 1, in the creation code, write a new comment, create player object, if bang instance exists. So if this object doesn't exist and the object is oPlayer, open two close parentheses, open curly bracket, close curly bracket, instance create layer, open parentheses. The horizontal location of where we want the player to be created is global.checkpoint_x, and the vertical location will be global.checkpoint_y. The layer, we want it to be the player layer, comma, and the object we want it to create is oPlayer, close parentheses, semicolon, and that's it. Now, we don't necessarily have to add this check if the oPlayer object doesn't exist. If we do our level design accurately and always remember not to add the oPlayer object, then it should be just fine, but I just add that to be safe oftentimes when I'm creating an object that I only want one of. So now in our R splash room creation code, we're going to alter some variables. So we need to set the checkpoint X and Y locations. And the way we're going to do that, in our level 1, I'm going to go back here to center fit here to get back to our room. We are going to find a good X and Y location for the player. So I'm going to just drag the player in temporarily. I will delete it. I'm going to put it where I want to place it. Right there. And then I'm going to double click it and get its X and Y location. So it's 416, 480. 416, 480. Notice how I immediately deleted the oPlayer object again. So the last step here, we need to make it so when the player touches an enemy or hazard, the player starts at the most recent checkpoint instead of the game restarting. To do this, all we have to do is change the game over code in oPlayer. So go to enemies game over. And instead of game restart, change it to a script that we're about to write, which is death, open close parentheses, semicolon. Now this is script. We haven't created it yet, so it acts like a variable right now, but all we have to do is go to scripts, right click, create script, call this death. And we're going to be using a lot of scripts in this tutorial. Just always make sure that the name of your script in the asset library matches the name of the function within the script. Now, those are different for a reason, and you can do different things, but to keep things simple for you as beginners, I just want you to keep the name of your script and the name of your function to be exactly the same, otherwise it won't work. And if you go over here, the asset library, and change it to say like game over, it may change it automatically, but if you change this to death, it will not change the name over in the asset library. So just always make sure those are the same. Call them both death. And we will write in here, if global.checkpoint_ID equals no one, close parentheses, open curly bracket, close curly bracket, room restart, which should never happen. I guess it should happen if it's the first room and we haven't touched a checkpoint yet. But else, if we have an active checkpoint, room, go to global.checkpoint_room. And that's all we have to do, because if we go to the correct room, it will create our player at the correct checkpoint. So let's check to see if it works. So right now, oh, I just touched, I'm going to try to avoid touching that checkpoint and hitting a hazard. It just restarts us where we need to be. But if I touch a checkpoint and then touch a hazard, restarts us at a checkpoint. So if I go over here and touch this checkpoint and then touch this enemy, it restarts me at this checkpoint. So it is working. So we just added a little script to universalize something to make it more smooth, let's also do that for our R level 1 creation code. So we want our game to run the certain creation code in every single room we create. And if you have 30 rooms, you all want it to have the same code, but you don't want to manually go to each room and change its creation code every time you update the game. So what we're going to do is I'm going to highlight this creation code and cut it, just Control or Command X. I'm going to write a new script name called room code, opening close parentheses, semicolon. And I'm immediately going to go over to scripts, create script, call it room code, and paste that stuff that I had over. Let's run the game, make sure I didn't add a bug. Yep, our game is working appropriately. So now we have a universal place where we can add new stuff to the creation code of any level that we create. Room code. Lastly, let's give some text so that the player knows that those flags are checkpoints. We're going to first create a new font. So over fonts, right click, create font. I'm going to call the font F default and choose a good font. Choose whatever font you like and set the size that you like. I think I have a font that I like on my computer, and different computers will have different fonts installed. So this will not be universal. And you can always download custom fonts at websites such as dafont.com, DAFONT.com, and install the font and then close GameMaker and reopen GameMaker, and you'll have those fonts that you can access. There's a font on my computer called Open Sans that I like for this game, and I'm going to set the size to be 18. Now you'll have to adjust the size of your font depending on your font, because some fonts are bigger, some fonts are smaller. You're just going to have to see what you like when you're running and testing the game. Let's see, I want the style to be bold. Yeah, so bold, size 18, Open Sans, close that. And we can always go back there and change it if it's too big or too small. Now in our checkpoint object, create event, add a create event. Let's declare some variables. Text fade equals 0, semicolon. Text fade underscore max equals 20. Buffer equals 5, semicolon. New comment. Buffer pixels on left and right of text for background rectangle. Text underscore y equals 60, which is new comment. How many pixels above checkpoint to place the text box. And then text equals, open quote, all caps checkpoint, close quote, semicolon. And you can write whatever you want here. I just like checkpoint in all caps. Now in the step event, we're going to add a new section, comment text, so that if we touch it, it gives us the text, and then when we stop touching it, it will slowly fade away. So if place meeting x, y, o player, close parentheses, open curly bracket, close curly bracket, text fade equals text fade underscore max, semicolon, comment no fading, text fade stays high. And then else, open curly bracket, close curly bracket, text fade equals max 0, comma, text fade -1, close parentheses, semicolon, reduce by 1 each frame until 0. So this is just altering the text fade variable, but now we're going to use this text fade variable in a draw event to draw the text. So add a draw event and write a big chunk of text. So first, draw underscore self, open and close parentheses, semicolon. So this tells the draw event, hey, still use the sprite that we have. If you don't have draw self, whatever you put in the draw event will overwrite the visuals of this object, and it will remove the sprite. So we need to have draw self there. Then draw set font, F default. So now we're going to set a bunch of values for our draw event. So we want the font to be the font that we created. Draw set H align. So the horizontal alignment, we want it to be center. So fa underscore center. draw set v align. I have a typo. Draw set h align. I misspelled align there. There we go. Draw set v align fa middle semicolon. Here we go. So now we need to get the dimensions of the rectangle that's going to be the background rectangle to the text, which is like a lot. So just bear with me. It'll be a lot, but it'll be useful. Var underscore half width equals string underscore width, open parentheses text, close parentheses, divided by 2, semicolon, divided by 2 plus buffer, semicolon. And I'm going to add some extra parentheses here to always keep track. You should, whenever you're dealing with order of operations in math, always do it with parentheses. Don't trust that the order of operations will be what you remembered from elementary school. So what this does is that it takes the width of our string, which is checkpoint, that it'll take the width of our string of whatever it is, and divide it by 2, and then add whatever buffer value that we added, and that is half the width of that we need for our text box. And what's great about the string width is that if you change the font, it will change the string width, and that's why it's super important that we set the font here so it knows what font to use when doing its calculations for the width. Similarly, var underscore half height equals string height text divided by 2. I don't need a buffer here, I think, because with checkpoint it's just going to be a single line, and I think there's enough buffer in the actual font, so we don't need to add the buffer. You can add the buffer there too if you like. I won't. Var underscore x1 equals x minus half width, semicolon. Var underscore y1 equals y minus half height minus text underscore y, which is how high we want to place the text box. Var underscore x2 equals x plus half width, and var underscore y2 equals y plus half height, semicolon minus, half height minus text underscore y, semicolon. So the reason why we have x1, y1, x2, y2 is because for drawing a rectangle, we need the top left corner location and the bottom right corner location in order to draw the rectangle. So x1, y1 is going to be the location of the top left corner, x2, y2 will be the location of the bottom right corner. Finally, if text fade is greater than 0, draw this stuff. And when text fade gets to 0, it will stop drawing these things. Draw set alpha, which is how transparent something is. If it's 1, it's 100% visible. If it's 0, it's transparent or invisible. And for this, we'll do text fade divided by text fade underscore max. So this will get us a percentage of how far away we are from text fade max. And so the longer we're away from the object, it will slowly fade out until it becomes invisible. Draw set color. I'm going to do C underscore purple. It'll just work with our sprite design later. Draw rectangle, open parentheses, underscore x1, comma, underscore y1, comma, underscore x2, comma, underscore y2, comma, and we're going to say false for it being an outline. We want it to be filled in. So if you do true, it'll just be a rectangle outline. And if we do false, it'll be filled in. Then draw set color. We're going to change the color to be C underscore aqua. And then draw underscore text x, comma, y minus text underscore y, which is what we're doing with all of our y locations, comma, text. Whew. And then lastly, whenever you're dealing with draw set alpha, at the end of your step of your draw event, you should also reset the alpha to be draw set alpha 1. The reason being is that stuff you do in your draw event will affect other things in your game. And so if you don't set your draw set alpha back to 1, everything in your game will be invisible when this is invisible. So it's important to reset that. So that was a lot, but it should work now unless I added a bug. I did add a bug. A draw event, half width not set before reading it. That is line 9. It's because I didn't add the underscore here for these temporary variables. So underscore, 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 underscore. Now run the game, see if it works. I touch a checkpoint, we get that text saying checkpoint, but when I walk away, it slowly fades out. So we get that nice fade out effect. Beautiful. Lastly, for this tutorial, let's add a combat system so we can defeat those enemies that are patrolling at the top of our level. First thing, open our level 1, close out of the creation code and hit center fit so it gets us back to our room. Remember, you can do those shortcuts where you hold command or control and use the scroll wheel on your 3-button mouse, which you must be using to zoom in and out, and then you can click and hold the scroll wheel to move your room around. In here, under layers, we're going to create a new layer, rename it to weapon. And I'm going to put it above the player layer. Could be below, it doesn't really matter. Go to close out of that, and we're going to create a new sprite, and we'll call this S weapon. Import, it's going to be in player sprites, S weapon 0 through S weapon 7. 8 images total. We're going to set the FPS to be 30, which it already is. We're going to set the origin to be middle center. Hit play to see what the animation will look like. Create a new object. Object O weapon. Set the sprite. S weapon. Let's add an attack key to O player. So O player step event. Minimize these regions, keep things nice and clean. So inputs, let's add a new key. Let's add a new key, then we're going to declare some things in the create event. So var underscore key underscore attack equals keyboard check pressed vk underscore space. Create event. Declare some new variables. Comment attack. Attack underscore cooldown equals 0. Attack underscore max equals 10. Semicolon. Comment number of frames before we can attack again. Now, you're going to see the code that I do for here. So there's an attack cooldown, so you can't just spam the attack. However, you don't have to do that. You can make it so you can spam the attack. You just don't do the code that we're about to write in the step event, and you should be able to see what you need to avoid writing in a moment. Back to the step event, minimize this, and let's add a new region after the sprites region. Call this region attack. End region. And we're going to add that cooldown code if attack underscore cooldown is greater than 0, close parentheses, open curly bracket, close curly bracket, comment if attack cooldown isn't 0, reduce it to 0. Attack underscore cooldown equals max 0, comma, attack underscore cooldown -1. And then here we'll write else, open curly bracket, close curly bracket, new comment. If it is 0, then player can attack again. Right. If underscore key attack, open close curly brackets, attack underscore cooldown equals attack underscore max semicolon, comment, set the cooldown timer, instance, create layer, just create it wherever our player is, which is X and Y. The layer should be weapon, the weapon layer, comma, the object is O weapon. Close parentheses, semicolon, comment, weapon. So we should check to see if it works now. So now when we hit the spacebar, it creates our weapon. Now, our code is not done. I just wanted to make sure it actually creates the weapon. So now we need the weapon to sort of move a little bit. Let me add a comment in my notes. We need to make the weapon move. There we go. So in the O weapon create event, write SPD equals 6, semicolon, comment, set speed. HSP equals 0, semicolon, comment, horizontal movement variable. And then still in the create event, write if instance exists O player, close parentheses, open curly bracket, close curly bracket, image X scale equals O player dot image X scale, semicolon, comment, set orientation. So we want the weapon to face left if we're facing left and face right if we're facing right. And the reason I always do a check to see if this instance exists first is because this is going to look for the player object and find the player object's image X scale value. And if the player object doesn't exist, we do not want to be adjusting this. And it's just a little, it shouldn't cause an issue. We could just put image X scale equals O player image X scale, but it's just a way to avoid accidentally inducing bugs later in your game if you change your code. Also add in that condition X underscore anchor equals O player dot X. So this is actually declaring a new variable called X anchor for our O weapon object. And then down here, still in the create event, if image X scale double equal signs 1, so we do double equal sign if we're checking the value of something, open curly bracket, close curly bracket, dir equals 1, semicolon, comment, set direction. Else, open curly bracket, close curly bracket, dir equals -1. So this will set the orientation this will set the direction of whether it's moving left or moving right. So it'll be oriented correctly and moving correctly. Now we need to add a different type of step event for our O weapon. We're not going to add a normal step event. We're going to go over to step, hover over that, and click end step. So begin and end step events are nice because it runs before all other step events or after all other step events. And end steps are great when you need other information to be calculated first. So for instance, we want to know O player's image X scale and the O player's location before we do any of these calculations. So all of that information is calculated in the regular step event. And if we add an end step event, we will already have that information updated, properly updated. New comment, lock to player's vertical position if instance exists. Again, this is just a cautionary way to code. O player, close parentheses, close curly bracket, open curly bracket, close curly bracket. If instance exists, O player, close parentheses, open curly bracket, close curly bracket. Oh, I already did that. Sorry. I was misreading my notes. This is a long video. Just write y equals O player dot y, semicolon, X underscore anchor equals O player dot X. So this takes the X and Y location of the player, and for our O weapon, it just sets the Y location of O weapon to be the same as the player. So if the player is moving up or down, the weapon sort of moves up and down the same way. And the X location, will be anchored to the player, but will still allow it to move with the movement code that we will write. Comment horizontal movement HSP plus equals SPD, semicolon, X equals X anchor plus open parentheses, HSP times dir, close parentheses, semicolon. So it takes our X, it takes whatever the player's X location is, and then it adds our HSP, and our HSP will be negative if we're moving left, and it'll be positive if we're moving right, and then that'll make that will be assigned to our horizontal location. Lastly, the last thing we need to do before we check our weapon here is add another event. Go to Other, Animation End. So after all of the frames of the sprite run, so it runs all these frames of the sprite, and after this, it will run this code, which is instance destroy. So get rid of the weapon after the animation ends. So let's check to see if I've added any bugs. Okay, so I hit the, so if I'm running with the weapon, it still sort of has movement with me. If I'm jumping, my little weapon sticks with me. And after it runs its animation, it stops, disappears. Now we want the enemies to disappear when the weapon hits them. Easy enough. Go to OEnemy, step event, and add at the very end, comment react to weapon if place meeting X, Y, O weapon, close parentheses, open curly bracket, close curly bracket, instance, destroy. Check to see if it works. So now our weapon should make the enemy objects disappear. And it does. And lastly, right before the enemy destroys itself, we want it to sort of explode. So to do that, we need to go to Sprites, create Sprite S explode, import assets, is it other sprites? Yeah, S explode 0 to S explode 8, open, origin, middle, center, frames, 30 frames per second, create a new object, O explode, assign the sprite we just created, S explode, add event, other, animation end, instance destroy, and then back to our OEnemy object. Instead of instance, right before instance destroy, add this code. Instance create layer X, Y, comma, quote, bad, end quote, comma, so it's the bad layer, O explode. So what this will do is that we'll create our little explosion object, then destroy the enemy object, so the enemy object will disappear, and then we'll see that little explosion, and then the explosion will disappear. So let's go up here to test it. You'll see a little explosion animation. Boom, boom. It's kind of nice, isn't it? We're going to use that same explosion animation for the player. We'll do that later, though. Beautiful. That's it for this tutorial video. I know it was super long. It's been over an hour, but we got through it. But you now have a combat system, you have wall jumping, and in the next video, we are going to create room transitions, fade-ins, fade-outs, being able to move to different levels. We're going to add a game camera that follows the player around big levels and a screen shake effect. It's going to be really cool, and I will see you there.